right, so go to number 3 on the bottom of the, it's actually the item sampler is what it's called. It's the most recent set of problems. Did we talk through these yesterday? It's for some of them. We did the one FRQ and then I had you do the other FRQ. If you were absent, you should go to Schoology and there's a blank copy of this. I'm going to call it item sampler, and you should really look through it, especially the very last FRQ. We did that one in class yesterday. Yeah, but some people were still gone, so that one I liked and it was a good one. Also, this is a really good multiple choice question because it's combining a bunch of stuff. So you've got your improper integral that you need to spot. Your notation doesn't matter when it's multiple choice, so go ahead and treat infinity like a number. But keep in mind, if you are doing an indefinite integral on a FRQ, which I highly doubt you would, but remember then that's where you say you're going to take the limit as b approaches infinity, and then you are going to go up to, and you keep using the b until the end, right? We're not going to do that for this one though. So you're supposed to find the constant k that will result in this improper integral equaling 1. I'm just going to get the k out of there and put it out front because k is some constant. So if you did it, fine, but if you didn't, I want to run through it because it combines so many different skills. So your original gut on one like this would be everybody's original gut, which would be to let u equal negative 2x. You'd run a little du either on your paper in your head and you'd go, okay, it's not that, but that is your go-to, right? Always run that, but you're going to abort that right away. So what's our other integration technique for this scenario? This is a open up to by parts, so you just have to decide, and this would be a Liate one because it's in, you can actually see what the functions are. So exponential gets killed by everything, so my u is the algebraic one, so I'm going to start that off. So my u is x, and my dv is the rest of the integrand, e to the negative 2x dx. And then, like we always do, your du is 1, and your v would be the antiderivative of that. So be very careful because I think if you do negative 2 e to the negative 2x, you get 1/4, and the answer is actually 4. So be really careful when you're doing this that you're integrating and you do your fraction correction. So I don't care if you do that in your head, but just make sure you don't accidentally. What I usually do right here is I would stop and just take the derivative to be 100% sure, because if that's off, the whole thing's off. So just quickly take the derivative of this expression in your head and just say, oh, derivative of e to the u is e to the u du, so my negative 1/2 does its job and it's good, because otherwise the whole thing gets thrown out of whack. So then you're going to go do your setup for by parts, which is to go this way and multiply. So I've got x times negative 1/2, so I'm just going to go like that, negative 1/2 e to the negative 2x, which I'm just going to put down here as e to the 2x. Are you okay with what I just did? And then that you need to still send it through your limits of integration. So, but that's the first chunk. And then when you go this way, we do minus, and then I'm going to do the integral, but it's going to be a negative 1/2, so I'm going to do a plus 1/2. So watch your signs really carefully. And then it would be e to the negative 2x times 1, and then this would be dx. And again, you're still running your limits from 0 to infinity. I'm going to go take care of this piece first. So what happens when I put in an infinity into both of these? What does that go to? Yeah, it goes to 0. You might think, well, no, it doesn't. It goes to infinity over infinity. Well, then just L'Hopital it, and it goes actually to 1/4e to that definitely. So if you need to verify that, but we've had that enough. So that's actually going to be a negative out front, and we've got a 0. And then when I put 0 in for x, what am I going to get? 0. Yeah, I accidentally, when I did this yesterday, I put it in, I got a 1. Did you know that? When x is 0 and you put in a 0, you get a 1. So I was like, Bree, where's my problem on this? Because I'm like, what is wrong with mine? But yeah, don't do that. Don't be dumb. Anyway, let's go to the next one. This is going to be plus 1/2. The antiderivative of this would be e to the negative 2x, but then what do I need to multiply it by? Negative, not negative 2. Negative a half, yeah, because of that whole, you gotta really watch the antiderivative versus the derivative. So I'm just gonna throw that negative 1/2 in here. And again, I would run a derivative through it just to make sure you have it right. But we're gonna run that through from 0 up to infinity. So let's go take a look at what I've got here. I've got 0 over here. I've got minus a 1/4. And then I like to pull all the constants out front and deal with the integral like that. This is really what I've got going. So infinity in first, and I would have 0, right? So I've got negative 1/4 technically, and I'd have 0 minus what? When this goes in, bam, 1. So the answer to that is 1/4. So K times, because remember I pulled the K out originally, has to equal 1. I pulled the K out way back when. So the answer to that one is 4. I just like this one because of it's kind of got a lot of stuff going on in it. Probably won't have one that involved because it takes so long. In the multiple choice, they like you to cruise through. I'm just going to talk about a couple other things and then I'll tell you what I would do if I were you. First of all, I want to discuss the integral test. All right. Just to be 100% sure you know how to use it, because you can avoid this one and we like to avoid it because it's the most involved one, so usually you try to do a limit comparison or a direct comparison or something else. But let's say, so if you want to just watch, go ahead. Suppose you had, I'm going to make one where you kind of almost, I'm thinking, yes. All right. That's what I want. I had to dig in my brain for a second for a problem. That's what I want you to do. So when you look at that right there, LNN. Yeah, sorry. LNN. Thank you. So if you look at that one, that's a little unclear. A lot of times you just know, right? You just look at it and you know. Here's why this is unclear. It's really close to 1 over n, which is what? Divergent harmonic. And by the way, any 1 over like 2n plus 4 is a divergent harmonic. 1 over n is this is a divergent harmonic, but anything with a linear denominator like that. Anyway, it's really close to a divergent, but the problem is it's under it. How do I know that? That's a good question, isn't it? Yeah, watch when I look at 1 over n and 1 over n ln n. This is smaller, right? Because the denominator is bigger, and I would need to be over that harmonic. That doesn't mean it converges, it just means I'm not sure it diverges. Same with comparing it to 1 over n squared, which is convergent. This is over that. So I'm not really quite sure what's going on. What does your gut tell you? Like if you had to guess, would you say it converges or diverges? And you should be kind of quiet like you are because it's a close call, isn't it? This has to be done with the integral test because the comparison part of it's not working for you. So remember what the integral test says. If you make that a function, right? 1 over x ln x. And if the integral converges, the series does. Not to the same thing, but it converges. If the integral diverges, then the series also diverges. So they have the same behavior. As long as, right, this is 3 things. What are the 3 things? Decreasing, continuous, positive for all the n's in your counting mechanism, which that is. Because n starting at 2, it's always positive. It's going to keep getting smaller and smaller, right? This is a perfect and one of the only really good candidates for the integral test. So what you need to do is integrate this. So now you're at an improper integral. And I guess if you were doing this, again, FRQ, which I doubt you would, but it's always nice to be prepared, then you would go from 2 to b 1 over x ln x, and you would work with this and keep the limit going. But I'm going to treat infinity as a number because that's not really what I'm trying to get at here. So how do I do the antiderivative of this? Who's u? Because this is a u. It's perfect. U is ln x and du is the rest of it. So if my u is ln x, my du is 1 over x dx. Ooh, naughty LaRue, you forgot the, I hate it. I've been getting all over Calc 1's case because I keep forgetting those, and then I just did. All right, so anyway, really what I'm sitting there with is the integral from 2 to infinity. I've got 1 over u, right? And the whole rest of this is du. So that's kind of nice. You have 2 options here. Let's see if you're, it's been a long time since we've done these. What are my 2 options? I could change my limits or I could just keep going. I'm just going to keep going because I'm just going to call this ln, right? Absolute value of u, but who's u? ln x. So this is ln of ln x, and I'm going to evaluate this from 2 to infinity. So when I put in infinity, what's ln of infinity? Infinity. What's ln of ln2? It's a constant, right? What's it? It doesn't matter, right? It's some number that's actually super small because the natural log function things are so small. So what's the answer to this? It diverges. Yeah, so you would say, therefore, your series diverges because the integral diverges. Does that make sense? All right, so one other thing, just up for discussion. Again, it's kind of hard to make these up on the fly. I probably should have had some forethought here. But let's suppose you had something like this and a 5 over 1 plus x squared from, I'm just making things up here. Let's go from, I don't know, let's try 0 to infinity. I'll try that. All right, so that's the integral. Let's suppose the series, though, had been n goes from 0 to infinity, 5 over 1 plus n squared. First of all, my option for this one would be to bring the 5 out front and deal with that. And that I actually do not need an integral test for. I'm going to run it, but what does that do? What does my series do? It converges for sure, right? As compared to 1 over 1 plus 1 over n squared is a convergent. That's always going to be under my convergent because n squared's less than 1 plus n squared. I mean, so that wouldn't require it. But suppose you had this. Watch me confirm it as well. Pull the 5 out front of the integral just like you would the series. The reason I chose this is because of this integrand. It's been a while. What is that? Arctan. Good call, right? That's arctan. So this is actually 5 arctan x. Now, just for, I was going to say shits and giggles on the microphone, but I'm not going to say it. That's kind of funny. What if that had been a... I've been reviewing way too much. What if that had been a 9? Then what do you have to have out front? This is still a squared plus u squared, right? Who's u? 3x. Who's du? 3dx. What has to come out front? Not a 3, but a 1/3. So watch out for that. But I'm just throwing what ifs at you because we kind of know how to do everything. But suppose I'm doing arctan x now from 0 to infinity. I chose this because if you have to, do you remember what arctan infinity is and what arctan 0 are? Because those are actually finite concrete numbers. What is arctan of infinity? Basically, I'm saying the tangent of what goes to infinity? Pi halves. Yeah, it's the asymptote on the tan graph. So that's actually a pi halves, a nice number. And what's arctan? 0. Yeah, it's 0. So the answer to this is 5 pi over 2. So the series does converge, right? Well, and I already knew that, but just I kind of tied the definite integral, the improper integral and the series things together. Does it converge to that? Does the series converge to that? No, the integral does. So all I know is this is falling off my head. All right. So I had one other thing I wanted to discuss. All right. Just a couple A-B things because we're kind of good. What are we laughing at? I know. Why did I do that? Suppose you had something like this. Do you remember, because we had to discuss this yesterday, do you remember what, because you're probably able to get this like off of a graph or a chart or a table or by hand. What does the adding 5 do to the value of the definite integral? It adds a rectangle. And so it adds how much area? 20. Yeah, awesome, because it moves the whole graph up 5, but it's spanning a width of 4. So it really just tacks 20 on to the entire. Now, actually, you could do that with an antiderivative, because what's the antiderivative of 5? 5x, and if you do that from 0 to 4, you do get 20, but that's kind of a waste of valuable time. The one other thing we haven't discussed for a long time, and then I'm just going to take you, come on, baby. What is arc length when you're in rectangular coordinates, not parametric? You're forgetting the very first thing. The integral from A to B, right? Square root of what? 1 plus what? I can't hear you. Thank you. It'd be that. So why am I, here's what sometimes happens is you'll get a revolving solid question that sometimes it'll look just like the AB ones were. So they'll give you some sort of a curve and then they'll go like that. And you'll have similar questions, like they might ask you to revolve it around an axis, around this axis, but sometimes your part C will be to find the perimeter of this. So if this was 4 over and this was 5 up, you would have 9 plus the arc length of the curve. You know what I mean? So do you guys remember how to revolve this way? Suppose you did, right? What do you do if you had to find the volume of that revolved that way? Right minus left, exactly. And this would be 5, right? Squared minus. It would be a dy problem, so don't forget you'd be going up from 0 to 5. I lied. This is going to be 4 squared because it's 4 over. But how about the inside? How do you deal with that when you're dy-'d? What do you have to solve for? X. Sometimes maybe one of the functions, we had one in Calc 1 the other day, that was a dy one, and theirs was, I think, e to the 2x, which kind of looked like this, but they were only dealing with this part of it, so they were dealing with that. If you had y equals e to the 2x, what's x? ln y, right? Divided by what? 2. That's what you would use. And again, I'm just, what if ln y over 2 comma y? So your inside radius would be there. And don't forget you do capital R squared minus little r squared, right? dx or dy. What goes out front of it? Pi. Do you need to go over one of those? Those has been a long time. Nope. All right, so what I'm going to do is take you through a couple slides just to be ready. Make sure your calculator's in radian mode. All ye AP physics people who took the physics test yesterday, get that sucker out of degree mode. Although you guys said you didn't need your calculators, did you? What? Okay. One question, did you have to be in degree mode? Yep, get it out. So you need to be in radian mode for sure to be good and ready. Be methodical and deliberate because some of you are only getting like 10 or fewer wrong, and so you're going to know most of them, and so you're going to go fast, and that's where you make the stupid mistakes. That's what I do. When I'm making the keys, my mistakes are always just the dumbest things. So make sure you slow down because you have so much time. Remember, multiple choice, a good thing to do is just kind of cruise along. If something disrupts your flow, just skip it and then go back to those at the end. Because when you get kind of one that throws you for a loop, it kind of rattles you for a little bit. So I just skip it over. Like if you're like, all right, I'm all the way through number 7, then number 8 is not one that's in your wheelhouse, or it's something really weird. Don't spend a ton of time on that. Go back to it because it makes you crabby. You know what I mean? When you get one of those ones where you're like, what? I can't get it. Just skip it and go back. But make sure you also skip it on your on your bubbles. Also, don't let the FRQs freak you out because there's always a weird one. If you didn't come in and say, I had no clue how to do number something something. That would be weird because there always is one. And I'll show you last year's so you can see they had a weird part to one and then they just had a downright weird one. But it just happens. So don't just sit there and quit because you said, oh, I had to take a 0 out of 9 or something. That might very well, not a 0. You better not take a 0 out of 9. But anyway, they also say don't erase, cross stuff out. Don't forget, we don't use pronouns. You guys know that pretty much. But no, it is increasing, it is decreasing, none of that. Read carefully and circle things. Like if it says, where is there a relative max? I would circle that word and I'd say, what do I need to know? I need to know where f prime changes from positive to negative and then go find it in the info. Next up, what else do I have? Existence theorems. These were more for AB, but do you remember what these are? Because it's been a while. What is this? Intermediate value theorem. What does it guarantee? Usually they use it for zeros because they say, you know what, if you went from positive to negative, that's why your calculator makes you zoom to the left and to the right. So it's looking for that sign change. But it really just says you have to hit every y value along the way, as long as the function is what? Continuous. All right, if the function is continuous and differentiable, do you remember what this one states? Yeah, slope of the tan line has to be what? Same as the slope of the secant line, someplace. How do you get the slope of the secant line? This is good stuff. F of B minus F of A over B minus A. Yep, this one right here is the extreme value theorem, and all it says is that as long as a function's continuous, it has to have a highest and a lowest point. It doesn't mean the derivative has to be 0, because that qualifies, right? It just says as long as it's continuous, it has to have an extreme high and an extreme low. It's so common sense, it's kind of not so fun. Rolls is just a spin-off of MVT. Do you remember what Rolls actually said that was a little different? Yeah, it said that if the secant line's 0, there's a place where the derivative is 0. So it's specifically that to both of these being 0. You don't need to know its name. Next, do you remember the difference between these two things? What's the average rate of change? 1 over b minus a integral a to b of the function. So if it's the average waterfall, waterfall function goes in here. If it's average velocity, velocity goes in here. What's average value? Oops, I lied. That's this one. Whoa! Super screwed you up. Average rate of change we just said before. F of b minus f of a over b minus a. That's a slope, it's a rate. And last up, top 10 biggest students' mistakes. That they assume if the derivative was 0, there's a max or min there. Not true. If the derivative is 0, there's a critical value there, right? But you could actually have the derivative being 0 a whole bunch of times and make a sign line like this. Maybe it was 0 at all of these and actually have no max or min. What does that function look like? Yeah, it's kind of like you're skiing. You know what I mean? You keep hitting a flat spot. Same thing they say with inflection points. Students say that there has to be an inflection point when the derivative is 0. Second derivative, not necessarily true. So do a sign chart. Also, when you're making a sign line, don't forget who goes on it. Critical values, right? And what else? Yeah, anywhere where the function has an asymptote. So let's say there's an x minus 4 on the bottom. Don't forget that because things can change to the left or the right of an asymptote, right? Or anywhere the derivative doesn't exist too. So you kind of got to be careful with that. You guys don't do this anymore, so I'm not going to talk about those. The biggest mistakes they say in the volume by washers is doing that instead of that. I don't think you guys do it. You better not forget Carl or I'll hurt you. Don't assume they know what it means, but you shouldn't be worried about that. You should, and you guys don't do the bottom part incorrectly either. So I'm going to move along. You know all that. You know all that too. I've got a question. How do you tackle, because this is talking about the derivative, how do you tackle the derivative of that one? Is that fresh in your brain? Because 5 goes to 0, but what's that one? Dump and derive. I don't think I need to talk about anything else. I think we're good. So what I would suggest you do is take your Calc Bible, which is at the front of your binder, it's the orange one, and take some time between now and tomorrow morning to look through it. Fair enough? I would. If there's anything in here, because I obviously can't review 2 full years of calculus, but if there's something you don't know, you guys are good at Riemann sums, you're good at particle motion, you should know by parts, solids. Do you remember the cross-section magic multipliers that come out front? If your cross-sections are squares, what do you integrate? Side squared. If they're isosceles triangles with the hypotenuse across the base, 1/4 side squared. How about leg across the base? 1/2. How about semicircles? Pi ace, and it's usually semicircles or squares. So kind of remember those magic multipliers that come out front, just in case. What if it was equilateral triangles? Root 3/4. Oh, your memories are awesome. And you don't need to know the shell method. You know slope fields. You should know Euler's. You got that down now? Okay, I had 2 of you that were forgetting that. Logistics, are we good with the carrying capacity and all that stuff? Partial fraction decomp, that's good. Arc length, you should be good. Improper integrals, good. Oh, how about second derivative parametric? Yeah, d squared x dy squared for parametric. Do you remember how to do that? Oh, ha, yeah, sorry. There. Do you remember how to do that? You do the first derivative, right? Which is dy dt over dx dt. So that's the first derivative. What do you do with whatever that is? Take its derivative, and then what? There it is. All right, that's a weird one and a hard one to remember, but if you, that's what I would use this for. Just kind of go through and go, oh yeah, hey, that I forgot. I'm going to be done. You do whatever you want for the rest of the hour. I would look through the orange thing. Do you see my